Hello, civil engineers. So I'm Stefan Lukic. I'm one of the founders of Civil's AI, civil engineering calculation platform. And I'm going to be showing you today how to find a free way to find the section properties of a particular section you might be designing. So if you go over to www.civils.ai, you're going to open up Civils AI, surprisingly. And here, if you go up to calculators, you're going to be able to go down to structural, and you can open up this section properties calculator here. If we open this up, what we're going to have here is a map where we can add sections and create shapes, and then analyze them and generate some results in terms of section properties. So what kinds of section properties do we calculate from this? So we can calculate the moment of inertia, the elastic section modulus, and also the radius of gyration for a custom profile. Very exciting, I know. So here what we can do is we can start adding rectangles to this space. So you'll see down here that we'll actually have let me move my face. If you see down here, we're going to have a center of the shape of the x coordinate, a center of the shape of the y coordinate. We're going to have a height, h, of the section, and a width, w. What we can do here is we can just straight away, let's hit analyze and see what happens. So we know we've got 100 millimeter height shape, 200 width. So we know that the area here is going to be 200 centimeters squared. We're going to calculate the moment of inertia along the x-axis, moment of inertia on the y-axis. We're going to generate the radius of gyration. Wow, my body appears to be sort of transforming. Yeah, wow. And then we're going to be able to calculate the elastic section modulus and the elastic section modulus of the other axis as well. So if we want to add more shapes here, we can start building, like, let's say, a custom eye section. So let's say this is going to be like 100 millimeters in height. So what we can do here is we can come down, center x, let's center it 0 on the x-axis. Let's make it minus 50 to the center of this piece down here. And then hit overwrite. And then what we can do is we can build this piece in here. Let's center it on the x-axis as well, overwrite 0. And then we can add another rectangle up here. Let's make sure it's the same height. So, okay, this one's a bit boring. Let's make this okay, this is wrong. Let's make this 25. And center it on the x-axis again. So 0. And then let's similarly create the same thing up here. So we're going to make this 25 and center it on the 0. And then this should be 33, I believe. No. No. Oh, okay, it's not in the dead center. Oops. So let's make this 0. Let's make this minus 60 then. And then this one up here should be 60 as well. Make sure it's at the center. And then what we're going to be able to do is run this as if it was an I-beam and generate our section properties and areas. So here we have our area, a moment of inertia. You can come over here to workings, and it'll actually show you how we're calculating this. So we're splitting it into smaller pieces, so you can create custom sections and break them down. And then each of these is using parallel axis theorem from the centroid of the shape. So here you can adjust the shape complexity. So if you're not happy with the results you're getting, generally you'll see here that the area percent error will be high if you think that this is inaccurate. Here we're getting a rough error. So this is an approximation, right? We're getting a rough error of 1.3%, which is fairly good. If we want to, say, make this higher and optimize this some more and get a more accurate result, we can adjust this shape complexity to high. So thank you very much for watching this video, and I hope you find this section calculator useful. Goodbye.